In this video, I'm going to cover nanotechnology and just a little about what's going on in the field for those who may not know and how to get into it. Now, like I explained in a previous video, which I will repeat here, nanotechnology is the manipulation of matter on an atomic and molecular scale in order to develop certain properties, like the mechanical, electrical, and magnetic properties as an example, that are not otherwise possible. How atoms and molecules are arranged for a given material gives insight to why certain materials break when being dropped, and why others stretch when being pulled. So if we can manipulate those atoms, then we can change those properties, like making glasses that don't break when being dropped. With nanotechnology, you'll be working on a 1 to 100 nanometer scale, or 1 to 100 billionths of a meter. But nanotechnology has a vast range of applications, from making better medicine to better computers, which I'll get into in a sec. First, what are some of the best majors to get into if you want to go into nanotechnology? Because at least in most undergrad schools, they don't offer nanotechnology as a major. So some of the best engineering majors to go into to set you up for nanotechnology are bioengineering, chemical engineering, electrical engineering, mechanical engineering, and material science and engineering. Then chemistry and physics are good sciences to go into. There's of course more, but these were the ones that came up the most. In terms of undergrad, some schools may offer a minor in nanotechnology or some elective classes, but if you want to dive into research, then you very likely will need to obtain a master's so you can actually specialize in nanotechnology. Be aware that you might not even see a hint of nanotechnology in undergrad, so you have to actively pursue it. So now I just want to give some examples of research that have been going on in this field. In electronics and computing, professors as well as a graduate student at the University of Illinois recently discovered a nanowire memory cell which will be used for superconducting computers. This consists of two superconducting nanowires, which are basically nanoscale rods that conduct electricity. Before this, scaling down memory cells to a nanoscale has been a challenge, but when done would allow for very fast computations by a supercomputer without dissipating heat. But this nanowires help solve this problem and will make supercomputers much smaller in size. Then a new type of nanosensor is being worked on that has the power to detect explosives like TNT, which could replace the need for sniffer dogs. The researchers looked into complex cage molecules that were essentially able to capture the explosive molecules that they are looking for. This could not only tell us if an explosive is present, but how much of it. Then electrical engineers have invented a sensor made out of carbon nanotubes, which I'll talk about soon, that can monitor the tread of tires in real time, which can tell drivers when the rubber that meets the road is growing too thin. The nanotubes or nanotechnology part came in because the sensors have to track millimeter changes in tread depth. When it comes to material science, physicists at Queen's University made extremely thin electrical conducting sheets. These might be able to revolutionize small electronic devices which control things like our smartphones to medical devices. The sheets they made are almost as thin as graphene, which is the thinnest material in the world. We are trying to make electronics smaller and smaller, but things are getting so small that it soon won't be possible to get any smaller. And one professor said to account for this, research might suggest an idea of an Etch-a-Sketch-like solution, where nanoscale electrical connections can be drawn, then wiped away as needed for whatever application, but this is not a reality at the moment. Another big one in material science is carbon nanotubes. These are tube-shaped materials made out of carbon that have desirable properties, like they are extremely strong and have desirable thermal conductivity and various electrical properties. These are already being manufactured, but we are finding new and better ways to put them to use. For example, recently NASA launched a rocket to test the viability of composite nanotechnology. Their computer simulations showed that carbon nanotube reinforcements on the spacecraft could lead to a 30% reduction in mass, which means way cheaper costs. They tested tensile properties of the carbon nanotubes against the conventional carbon fiber composites to see which was better. Then graphene, like I said, is a very important material. This is the thinnest material in the world at 1 atom thick, which is just a single layer, and is also the basic structural element of carbon nanotubes. Graphene is 200 times stronger than steel and conducts heat and electricity very well, and is also very light. So one experiment that was recently conducted was to show that graphene could help in the automobile industry. For a competition, students fabricated a lighter hood that was created from graphene. They conducted a test that would replicate a crash at 30 miles per hour, and it was reported that the hood was able to deform, then bounce back to its original form. Graphene is also being used to look into smaller and faster electronics, as well as thin and flexible display screens. Next is medicine, and there are many articles saying that nanotechnology is the future of medicine. So this is a big one, and a really common topic I saw was drug delivery, as in ways to transport a compound in the body. Nanotechnology is allowing injectable cancer medicines to be delivered in smaller volumes while increasing the amount of the drug, which would help reduce medication errors. Researchers are also looking for ways to destroy cancerous cells from within a tumor. As an example, they want to use nanoshells, which are a type of nanoparticle, which they design to absorb light of different frequencies and generate heat. Then when inside the tumor, the intense heat generated can kill tumor cells without harming healthy ones. In 2004, chemists at NYU made a nanobot from fragments of DNA that was able to walk on 2 legs that were both 10 nanometers long. When this was made, one goal from the scientists was to one day have a molecular scale assembly line where a molecule could be moved and put into place by nanobots, just like with a car assembly line, but this time on a nanoscale. In terms of medicine, the ideal innovation would be to have nanobots within your bloodstream that basically patrol for tumors and various abnormalities that could cause harm. Although at the moment that is just not a reality, maybe one day it will be. And also note how biology or biochemistry that weren't listed before are also majors you can get into if you want to go into nanotechnology, and something you can look into is bio-nanotechnology, which would be a field that might interest you for those interested in biology and medicine. So as you can see, there's a lot going on in this field, and maybe one day cancer will be cured by just a shot. The nanotechnology applies to a lot more. In terms of solar energy, nanotechnology is helping to improve materials efficiency and reduce the cost of manufacturing. Nanotechnology is also being used for water and air treatment. For example, they made something called a drinkable book, which isn't exactly what it sounds like, but it's a book where every page is actually a filter that you can tear out, and that filter is comprised of nanoparticles that kill bacteria and can turn raw sewage into drinking water. One way food scientists could use nanotechnology includes using nanosensors to identify any diseases that will be harmful to consumers. They're also conducting research on ways to use nanotechnology to keep food fresher for longer periods of time. Overall, nanotechnology is a very wide field that includes electronics and semiconductors, automotive applications, aerospace applications, sporting goods, and so on. In school, no matter what your major is, you may want to look into taking certain chemistry courses as well as some quantum physics courses, as those pertain to the small scale and will lay a foundation for further education in nanotechnology. And again, since it's a very broad discipline, you can have 2 people really interested in nanotechnology but go 2 totally different paths. Maybe one majors in electrical engineering in undergrad and the other in chemistry. One takes electives in nanoelectronics while the other in organic nanomaterials. They probably should both go on to get at least a master's. Then the EE could look into research for making better semiconductor devices for our electronics. And when working on this, they might have to take a top-down approach, which is basically taking a larger material and removing parts to eventually get what you want on a nanoscale. Imagine trying to make the world's smallest computer chip the other way and assembling everything atom by atom. That would be much tougher, which is why they use the top-down approach. Then the chemists might want to go into research on making better nanobots that can assemble molecules. That example I gave of this earlier was done by chemists. And they use more of a bottom-up approach where they work with assembling atoms and molecules like Legos. So even though nanotechnology is on a nano scale, what these 2 individuals would do in a lab would be much different. So be sure to look into what interests you most, because as you can see, there's a lot you can do in this field. If you like